This is the video guide for the Unit 1 review for Honors Chemistry. When thinking about significant figures, the thing I try to remember is this, the old Atlantic Pacific rule, right? So here's the United States, okay, and we know the Atlantic Ocean is over here. We know the Pacific Ocean is over here. And so basically this Atlantic Pacific rule states is that if there's a decimal point present, you start from the Pacific side, the left side, and you go until you hit the first thing that isn't a zero, start counting there, and then everything to the right. For the Atlantic rule, if the decimal point is absent of Atlantic, you're going to start from the Atlantic Ocean side, the right side, and go right to left. You start counting at the first non-zero, and then everything that follows. So looking at this first measurement, present, so we start here. Here's the first non-zero, everything after, 3 sig figs. For 13,000 meters, there's no decimals, so it's absent, so I come this way. This is the first non-zero and everything here, 2 sig figs. For the next part, it says present, and so we start at the Pacific Ocean. We come here to the first non-zero, everything after, 4 sig figs. 14.0 grams present, start here, everything after, 3 sig figs. And then let's see, when scientific notation numbers, you only look at the numeric part. You don't consider the times 10 to the power of present. So we start here and everything after, 3 sig figs. For the next part, it wanted us to convert each measurement to 2 significant figures. So for this one, well, the 2 significant figures would be these two. So the 0 doesn't count, just these two. So it would be 0.72 meters. For this one, it already has 2 sig figs, so you could just leave it as is, or if you wanted to convert it into scientific notation, you could move the decimal, you could go to the left 1, 2, 3, 4 spaces, so you could write that as 1.3 times 10 to the 4th meters. That's an equivalent thing. So 2 sig figs with scientific notation, just one number in front of the decimal has to be between 1 and 9, it cannot be 0 or greater than 10. Okay, this one with 2 sig figs, it's going to be these two, so it'd be 0.0051 kilograms, or you could write that as 5.1 times 10, and if we go to the right, 1, 2, 3, it'd be negative third kgs. Okay, this has 3 sig figs. To give it 2, you just write it as 14 grams. And then this one, to write it with 2 sig figs, it'd be 6.0 times 10 to the negative 2nd grams. So you just omit that 0. Okay. Okay, for this next one, we're doing multiplication and division. So for the math rules for significant figures, multiplication and division, basically what you do is you look at your measurements, the measurement with the least number of significant figures, you round your answer to match that. And then if you do any addition and subtraction, we'll do that here in a second. But multiply and divide, you're looking for the fewest sig figs. And so if I put these two numbers in my calculator, I get 26.52 square meters. Well, this has 2 sig figs. This has 2 sig figs. My answer has to have 2. So it's going to be these two. Because this is 5 or greater, this rounds up 27 square meters. We have 7 times 9.8, punch that in the old magic box, and you get 68.6, and this is going to be square centimeters. This has 3 sig figs, this has 2 sig figs, so we're limited to 2. Once again, it's the same kind of deal. This is 5 or greater, so this rounds up to 69 square centimeters. Division, 6.88 square meters divided by 2.6 meters. Punch that into the old magic box, you get 2.646153.846. Okay? A meter squared divided by a meter is just a meter. Here we have 3 sig figs. Here I have 2 sig figs. We're limited to 2. It's these two, 2.6 meters. 52.98 divided by 1.8, it's going to spit out 29.433333, just 3 repeating. Okay, and this is going to be grams per milliliter is the unit. We have 4 sig figs here. Here we have 2 sig figs. We're limited to 2, which is going to be these two, 29 grams per milliliter. This one we're multiplying, so I take 1.56 times 0.864 times 14. My calculator tells me it's 18.86976. Okay? 3 sig figs, 3 sig figs, 4 sig figs. My answer is limited to 3. Because this is greater than 5, it's going to be 18.9. And this is going to be cubic millimeters. Millimeter times a millimeter times a millimeter is a cubic millimeter. Okay, for this one, we're doing addition and subtraction. So the rule for addition and subtraction states that you must round your answer to have the same number of significant, or excuse me, not significant figures, but place values. Place values. So usually it's going to be decimal places. One of them's a little goofy here, but that's okay. I add these two numbers here on my calculator, and my calculator spits out 20.62 meters. 2 decimals, 2 decimals, 2 decimals. That's my answer. This is the one that's a little squirrely. If you subtract these two numbers, your calculator is going to tell you 685.8 grams. Okay? Notice this has 1 decimal. Now, granted, this doesn't have a decimal, so you might think, oh, I should round it to 686. However, notice there isn't a decimal point here. That means that it's not significant. Okay? The thing that's been estimated is here to the tens place. Okay, if there were a decimal point present here, then you would round to the ones place, but because there's no decimal, this means that it's 820 grams accurate to 10 grams. So we're actually limited to the tens place value. Well, if I round this number to the tens place value, because this is a 5, this rounds up 690 grams. So that's kind of a goofy one. We generally don't do them like that, but that's how it works. For number 3, we're going to take those 3 numbers and add them together. Your magic box is going to poop out 0.5112, and this is going to be centimeters. Well, 3 decimal places, 4 decimal places, 2 decimal places, we're limited to 2, so 0.51 centimeters. And lastly on this one, we're subtracting, put these in my calculator, 41.54 milligrams. Well, 1 decimal place, 2 decimal places, we're limited to 1 decimal place, 41.5 milligrams. Okay, we're doing some scientific notation. Remember, scientific notation, you can only have 1 digit in front of the decimal, and so it's got to be a number 1 through 9. And so if we take an implied decimal here and we need to move it to this place, 1, 2, 3, 4, 5, as we move the decimal to the left, the power gets larger. And because there's only 1 sig fig, you only include sig figs with scientific notation. This is 5 times 10 to the 5th. This guy, we're going to move the decimal over 1, 2. And so this is going to be 2.852 times 10 to the 2nd. So you include all significant digits. Okay, this one we're moving to the right, and so notice we want to get the decimal here, so we're going to go to the right 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to record this as 4.2 times 10 to the negative 8th. Anytime you have, these small numbers, the ones that are much smaller than 1, as you're moving the decimal to the right, the power becomes more negative. Okay, for number 4, same thing. We're going to go over 1, 2, 3, 4. This is going to be 2 times 10 to the negative 4th. This guy, 83,700,000, so there's an implied decimal here. We're going to go 1, 2, 3, 4, 5, 6, 7. So 8.37, none of these zeros are significant, times 10 to the 7th. All right. Reverse. We're going to write these numbers in standard form. Okay, so we're just kind of undoing what we just did. Okay, so when you have to the negative 3rd, so if you see a negative power, you know that's a tiny number, smaller than 1. Anytime you see a positive power, you know that's much greater than 1. And so to undo this, we got to move the decimal to the left 3 places. So we have that kind of implied decimal here, and so we're literally going to go 1, 2, 3, and so it's going to be 0.004. Okay, same thing here, so 3.4 times 10 to the 5th. This time, since we know it's much larger than 1, it's a positive value. To undo it, we've got to move the decimal to the right. And so we're going to go, so here we're moving at 1, 2, 3, 4, 5. So it goes 340,000 is that number. Okay, same thing here, 4.5 times 10 to the second. So we're going to move it over 1, 2, it's 450. Notice you don't want to put a decimal here because it's not 450. If it was 450, you would put a decimal. But because there isn't, you leave it just like this. Okay, next one, 5.9 times 10 to the negative 6. So we're going to move it, so we're going to start with the 9. And so here is 1, 2, 3, 4, 5, 6. And then I generally put this leading 0 because sometimes otherwise I miss that decimal. So it should be 1, 2, 3, 4, 5 zeros, and then 5, 9. Okay, this one 5.70 times 10 to the negative second. Okay, so same thing. We know this is smaller, and so we need to start out with, we have to include the 570. And so it moves over 1, 2. So here's 1, here's 2. So it's going to be 0.0570.